Good morning and thank you to the organizers of ICDTDE 2025. I am Husna. We stand at a pivotal moment for our industry. We have mastered the art of building up and building fast. But now we face a more profound question. How do we build around? How do we create structures that are not endpoints, but parts of a continuous cycle? Today, I will explore this through the lens of research in Closing the Loop, Circularity in Modular Construction. For generations, construction has followed a linear path, which are extract, manufacture, build, demolish, and discard. This take-make-waste model has created an environmental crisis. Our industry generates over a third of the world's waste and nearly 40% of global carbon emissions. Each demolished building represents not just the end of a structure, but a catastrophic loss of embedded energy, materials, and value. This is fundamentally unsustainable. Therefore, the alternative is a circular economy. Circular economy is a regenerative system that eliminates waste by design. Instead of a straight line, we create continuous loops where materials retain their value. This means designing for disassembly using non-toxic, separable materials and viewing buildings not as permanent monuments but as temporary assemblies of valuable components. The goal shifts from creating disposable buildings to managing material banks. Now, why is modular construction particularly suited for this circular transition? Modular buildings are pre-designed for assembly. This gives us a critical head start in designing them for disassembly. Their standardized components are more easily cataloged, recovered, and redeployed. Factory manufacturing provides material traceability that is nearly impossible on traditional sites. Essentially, modular gives us the physical and procedural foundation for circularity. Therefore, our research examines circularity through 4 interlocking loops. The first one, we call it the technical loop, which is developing reversible connection systems and material passports. The second is the digital loop, which is creating BIM protocols for component tracking through multiple life cycles. The third one is the business loop, which is exploring new models like material leasing and performance contracts. And the final one is the policy loop, which is understanding how regulations must evolve to enable, not prevent, but reuse. Let's dive into one technical challenge, which is deconnections. Traditional construction relies heavily on permanent connections, such as welding and cast-in-place concrete. In contrast, circular modular construction emphasizes reversible mechanical connectors. Studies have tested mechanical demountable connectors that maintain structural integrity while allowing non-destructive disassembly. The data shows some promising candidates achieving 90% of traditional strength while enabling multiple disassembly cycles. But technical solutions need digital support. Research has developed material passport systems where each modular component carries a digital twin containing its material composition, structural history, maintenance records, and disassembly instructions. Studies have reported increased potential recovery rates from 35% to over 80%. The component does not lose its identity when the building changes function, but it accumulates value through documented reuse. Despite progress, significant barriers remain. Economic misalignment, which the developer who invests in circular features rarely captures the end-of-life value. Next, regulatory ambiguity. Building codes do not account for reused components. Market immaturity. There is no established marketplace for certified used building components. And the final one is a cultural resistance within the industry. Research has identified three critical pathways, which are developing circular procurement standards, creating second life certification protocols, and establishing material banks with guaranteed buyback schemes. In conclusion, modular construction is not just a delivery method, it is a prerequisite for true circularity in our industry. But technology alone will not close the loop. We need integrated research that addresses technical, digital, economic, and policy dimensions simultaneously. The vision is audacious but achievable. Buildings as material depots, construction as service provision, and waste as design failure. By treating every building as a future resource bank, we can transform our industry from the planet's biggest consumer to its most careful steward. I would like to end with this key message. The most sustainable building is the one already built, or at least the one whose materials live on. Thank you for your attention.